So we're given this problem. It says a Boeing 737 aircraft maintains a constant airspeed of 500 miles per hour, headed due south. So I can actually draw this headed due south. And I lost my place. The jet stream is 80 miles per hour in the northeasterly direction. Who talks like that, right? Northeasterly. So remember your never eat soggy waffles? I don't know, a student told me that and never forgot it. And so northeasterly would be cut right in the middle. So that would be 45 degrees. So from here I can label things. So in fact it said to use this for the jet stream, and then for the air, now this is 500, it was what, 500, I'll get my piper here, 500 miles per hour, but it's south, so it has to be negative, okay? So we know that this is going to be my vertical component. All right, so then from here, what it wants me to do is it wants me to actually find this vector. So if I'm looking for that vector, then it gives me that it was going 80, okay, was the airspeed. And then we know we break down our components into cosine. In this case, we're at 45 degrees. I plus sine 45 degrees J. Okay, so that's going to give me my horizontal and vertical component. So of course from here I can find the cosine of 45 degrees, which is square root of 2 over 2. And then sine of 45 degrees, square root of 2 over 2. And then just make it look a little bit better, 40 square roots of 2 and 40 square roots of 2. Okay, so that is my vector for the jet stream. All right, and then it wants the vector for the airspeed. Well, it kind of gave it to you. But to write it as an actual vector, then again we use the J. Why? Because that's the vertical component. All right, so that's the first answer. And I lost my paper. So then part B says, find the velocity relative to the ground. Okay, so if I'm looking at relative to the ground, then I would find that. So I'm going to call that, that color ain't looking too good. Let's see. Yeah, maybe. I would find this by simply taking these two vectors and adding them together. And so in other words, I'd have something like right here with the ground. Ain't liking the color. Let's give blue. All right, and so then of course here I've just simply plugged in everything in based off of that, which was 40 square roots of 2, that was a bad arrow, I plus 40 square roots of 2j, and then of course minus 500j, and I could simply put the vertical components together. So this would be 40 square roots of 2 minus 500, and that would be my vertical component. All right, one last little piece to go. So the last part said find the actual speed and the direction. So speed meaning the magnitude. So speed, can't go too much lower, huh? In other words, and it says relative to the ground in the question. So would be this. And so I can just see based off of this one up here, what I'm going to do then is I'm going to square root for my magnitude, the 40 square roots of 2, that's my I component, plus the 40 square roots of 2 minus 500, my j component. And if you, ooh, you hear Scotty? And if you do that, you should get 447 miles per hour. All right, and then finally the last piece, can I write up here? Yeah, let's see if I can write, well, yeah, I better go up here. So the last piece, to find the direction. So I'm gonna look for the angle, and I'm gonna do that. You have the formula for finding the angle. So 40 square roots of 2 minus 500 over 40 square roots of 2. And please don't forget when you solve this, two things. One, to solve it for alpha, you need to do tangent inverse of both sides. And then also, getting a little high there, also be sure you're in degree mode, and you should get negative 82.7. Okay, now the only problem with that is we tend to typically like to have our degrees positive. So because I know it's this way, then I can just take 90 minus that value. Make sure I'm not going off the board. And I get 7.3. So this equals 7.3. And that would be in the southeasterly direction. So that would finish up that problem. Ta-da!